This is section 10.2, part 2. All right. So now let's apply the cosine difference identity to voltage. Application problem. Common household electric current is called alternating current because the current alternates direction within the wire. The voltage V in a typical 115 volt outlet can be expressed by the equation V equals 163 sine of omega t, where omega is the angular velocity in radians per second. Radians per second. Of the rotating generator at the electrical plant, and t is the time measured in seconds. Okay, so A. Electric generators must rotate at 60 cycles per second. So household appliances and computers will function properly. Determine omega for these electric generators. So let's see. Omega. Omega is in radians per second. So I've got 60 cycles per second, which is kind of an angular velocity, but it's not in the units I want. I want to get rid of cycles and create radians. So how many radians are there in how many cycles? Well, one cycle gives you 2 pi radians, one full revolution. And so doing that multiplication, you get 120 pi radians per second. Notice I don't give a decimal for this. I want the exact answer as often as you can get it. That's the preference. Unless they had said approximate it, and then you would round. It says graph V on the interval between 0 and 0.05 seconds. Okay, so to graph V, I'm going to do the graphing like we did in the previous section. The amplitude is the absolute value of the number in front of sine. So the amplitude is 163. The period is 2 pi divided by omega, which is the number in front of t, our variable. So that's now known to be 120 pi, and that simplifies to be 1/60th. And by the way, the 60 cycles per second, notice that that's the reciprocal of the period. That's kind of a nice thing to know when you're in a physics class, is that the period of the sinusoid is the reciprocal of the frequency. At any rate, that's the period. The phase shift is 0. And the baseline remains y equals 0. Okay, so you see we're supposed to graph this from 0 to 0.05. So let me think, how do I want to do that? Well, since the period is 1/60th, we should probably divide that by 4 to get our marks on the x-axis correct. So each mark here is worth 1/240. Now to see how many of those I'm going to need, I'm probably going to need to convert that to a decimal because I'm supposed to graph all the way to 0.05. So I do want to make sure I do that correctly. Okay, that's about 0.00417, give or take. Okay, so if I divide that into 0.05, I can see how many marks I'm going to need. And so 0.05 divided by that answer is 12 marks. So hope I have enough room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marks. Should do it. Now this is actually the t-axis, not the x-axis. And in reality, this is the v-axis. And since the amplitude's 163, I can just declare that this is where 163 is. And of course, negative 163, its opposite is down here. All right, so I think I'm ready to graph. The sign of 0 would be 0. So the next mark will be at the high, middle, low, middle, high, middle, low, middle, high, middle, low, middle. And then draw, whoops, that looked kind of straight up there. Make sure it's a curve and it doesn't look like a V. That one was a little bit better. Well, it's still not great. Just be careful. Try to make it look like a nice smooth curve, and it shouldn't be a V looking thing. Like my second high point doesn't look too good to me. But that's okay. I'll take it. So that bad. All right, so moving on. Part C. Yeah, there is a part C. I'll make sure we do everything that we're asked to do. Okay, for what value of phi will the graph of, so phi is what we're trying to find, phi equals 163 cosine of omega t minus phi be the same as this graph? Okay, so one of the things I need to make sure that I pay attention to is that for the phase shift, which is what they're getting at here, to be useful, that omega has to be factored off of the t so that it's 1t inside the parentheses. And if I factor omega off of the omega t, I have to do the same thing, which will leave phi over omega. Okay, so what I have to figure out is, what is my phase shift up here so that it's a cosine graph? In other words, remember, 0 cosine is at the high, so it's been shifted to the right. So the phase shift that we're going to accomplish is 1 over 240 to the right. And so for that to happen, that means that phi over omega has to equal that shift amount, 1 over 240. Because recall, this number in here is your phase shift. Okay, and so we're trying to solve for phi, so we're going to multiply both sides by omega. Almost looks like a W instead of an omega. not very pretty. But anyway, our omega that we got earlier was, how big was omega? 120 pi. 120 pi. So let's make this 120 pi divided by 240, which is pi over 2. Okay, so I think that does that problem. Get pi over 2. Perfect. Alrighty. So let's go on to another problem. Finding function values and the quadrant of a plus b. Alright, so let's do some of this. Suppose a and b are angles in standard position, and that sine of a is given to be 4/5. And furthermore, let's stipulate that a is between pi over 2 and pi. And our second piece of information is that the cosine of b is equal to negative 5/13. And furthermore, b is between pi and 3 pi over 2. And it says to find several things. Well, before I find all those things, kind of looking ahead like sine of a plus b, we're going to need to know sine of a, cosine of b, cosine of a, and sine of b. Some of which we know, but some we don't. So let's remember that sine, I probably should have given myself some more room, but I didn't. Anyway, sine is y over r. And so I can safely assume that I could let y equal 4 and r equal 5. And if I'm supposed to find cosine of a, I'm going to need to know what x is. So using the Pythagorean formula, x, which I don't know, squared, plus y squared should equal 5 squared, which means x squared is equal to 9, which means x is equal to what? Be careful, when you take the square root of both sides, you have to put in a plus or minus, unless it's r, because r is always positive. But here x can be negative, so don't forget to put in the plus or minus. Now, to determine which of those two it is, think about what they told us about angle A. It is between pi over 2 and pi. It's somewhere in there. And if you look at that quadrant, quadrant 2, what kind of number is x in that quadrant? It's negative. So that means that x is negative 3. So that means that the cosine of a, which is always x over r, is negative 3 over 5. Okay, I'd like for you to do the same thing and see if you can figure out sine of b all by yourself. Pause the recording and come back. All right, let's see how you did. We know that cosine is, oops, forgot to change color. We know that cosine is x over r. So we could safely allow x to be, oh wait, if it's negative, which one of those could be negative? R or x? Well, it has to be the x, because r is always positive. So we could let x equal negative 5 and r equals 13. So that means we need to find y. It's the one we don't know. So x squared plus y squared equals 13 squared. So that means y is equal to plus or minus 12. And to make the decision about what angle that is, we're told that b is between pi and 3 pi over 2. And what kind of number is y in that quadrant? It's negative. So that means that the sine of b, which is going to be y over r, is negative 12/13. Okay, so now we have all the information we need to do all of those problems that they ask us to calculate the value for. So let's look at the first one, A. Sine of a plus b. So that's sine of the first, cosine of the second, keep the sine, cosine of the first, times sine of the second. And now substituting in the answers we found, sine of A was given, it was 4/5, times cosine B, that also was given, negative 5/13, plus cosine A, which we calculated to be negative 3/5, sine of B, which we calculated to be negative 12/13. And so do that arithmetic, and you should get 16/65. Okay, so that one's done. Now let's do part B. Part B is tangent of A plus B. Okay. Tangent of A plus B. Well, I didn't find everything I needed, as it turns out, but that's okay. So that is tangent of the first, keep the sign, tangent of the second, divided by 1, change the sign, tangent of the first, times tangent of the second. So over here, I'm going to find tangent A and then tangent B. Tangent of A is y over x. So our y was, go back up here, y was 4, and x was negative 3. So tangent of A is negative 4/3. Tangent of B, which of course is also y over x, but for angle B, y was negative 12, and x was negative 5. So that's 12/5. So by substitution, that's negative 4/3 plus 12/5 divided by 1 minus negative 4/3 times positive 12/5. So this is a complex fraction, and we talked about that a few minutes ago in an earlier recording, I believe. And I'm going to find the common denominator of all the little fractions. Well, 3's and 5's have a common denominator of 15, so I'm going to multiply that big fraction in the form by 1 in the form 15/15. So when I multiply negative 4/3 times 15, I get negative 20. And then when I multiply 12/5 times 15, I get 36. And 15 times 1 is 15, minus a negative is plus. And then if I multiply 4/3 and 12/5 times 15, I'll get 48. And so that is 16/63. I'm assuming I did the arithmetic correctly. Hopefully someone will double check that. Yep, I think that's correct. Okay, part C. What is the quadrant of A plus B? Well, let's see. the sine of a plus b was positive. And since sine is y over r, and r is always positive, that means that y is going to be positive for angle a plus b. The tangent of a plus b, we just found, was also positive. And since tangent is y over x, and we already know that y is positive, what would I divide a positive by to get a positive answer? Well, that means x has to be positive as well. And so for all of those reasons, we can say that a plus b is in quadrant which one? Where are y and x both positive? That's quadrant 1. Okay, and that's the end of these notes. I will see you in class.